Hello and welcome to my class. In this video, I'm going to be explaining to you the different types of chemical reactions we have in chemistry. Now, the diagram you can see up here is a certain type of reaction, a type of chemical reaction we call chemical decomposition by heat. Also, we have another type of chemical reaction we call precipitation reaction, and like some of you have already done in the UPSS multipurpose lab, is a type of reaction where you have two substances which are perfectly soluble and transparent in color come together and give you a colored precipitate. That also is another type of chemical reaction. But this week we are going to be discussing about a certain type of chemical reaction that's one of the most common in chemistry lab, and that reaction is called oxidation and reduction reaction. Now, this reaction is very, very common, not just in the lab but in our everyday environment and experiences. For instance, you can see in the slide here that I have a boat, or we call it a screw now. But you can see that it has corroded. It has what some of you will call rusted. As you can see here, it has what become an iron rust. And the type of reaction that occurs for this particular iron to rust is called your oxidation reaction. You can also see another example here of a burning coal. Another example of oxidation and reduction reaction we find in our everyday life. Now, it is important for you to know that this oxidation and reduction can also be called redox reaction. And redox reaction is basically a combination of the two words. Redox here for red from reduction, and oxidation as you have it here. So we can combine the two words, and instead of calling it oxidation and reduction, we simply call it redox reaction. Please take note of that. Redox reaction. Good. Now we can define oxidation and reduction reactions or redox reactions in different terminologies, and that's why it is one of the most common type of reaction we're having in organic chemistry and extensively in organic chemistry also. Now, we can begin by defining in terms of oxygen. As you can see here, we can define in terms of oxygen. And when we want to define in terms of oxygen, let us begin with oxidation. What is oxidation? Oxidation is basically the addition of oxygen to a substance. The addition of oxygen to a substance. That means I have a substance and it reacts with another substance, but at the end of the day, this substance that was not having oxygen when we started is not having oxygen at the end of the day. I will give you an example here. You can see this example. This is iron. This is the iron method as an atom, as you have it here. This is iron. Now it reacts with oxygen when it is exposed to oxygen, and this is a process that commonly happens in the reduction of metals. Let's say your nails, your stainless steel, where you expose them to the atmosphere. Now what happens is that the oxygen gets added to the iron metal, and what happens is that the iron gets oxidized, as you can see here, oxidized to iron 3 oxide. I'm sure you will observe the fact that in this place there is no oxygen in this iron, but here there is what? Oxygen. And how can you detect that? By seeing it. At the onset, this iron usually has that silverish color, but when it gets oxidized to iron 3 oxide, it now has that brownish color like we have in the nuts or boats I just showed you earlier. That means iron has been oxidized to iron 3 oxide. So that's basically oxidation. I'm sure you can find more examples for me of the oxidation process. You know, when oxygen reacts with zinc, oxygen reacts with magnesium, and so on and so forth. But let's move on to talk about reduction. What is reduction? Reduction is actually the opposite of oxidation. In sharp contrast, it is the removal of oxygen from a substance. So in this case, let's assume we have a substance here now, and that substance has oxygen. Like you can see here, this is lead 2 oxide. Yes, lead 2 oxide, and you can watch here, there's oxygen. But lead 2 oxide reacts with a substance, as you have here, carbon, which in this case is a strong reducing agent. We are going to be talking about reducing agents and oxidizing agents in our next class. But what that means is that it is the agent that brings about reduction. What was going to happen is that this carbon is going to remove, remember the word now, remove oxygen from lead 2 oxide. And what is going to happen to lead 2 oxide? Lead 2 oxide will be reduced. Take note of the word reduced. That will undergo reduction to give you lead as an atom. But watch here. Lead 2 oxide has been reduced to lead, but you can observe that carbon here was without oxygen. But in the product side, at the end of this reaction, is now going to be having oxygen attached to it. And what can you tell me is the process that happened there? Guess, you got it right. It's going to be what? Oxidation, because oxidation is the addition of oxygen. So carbon now has oxygen added to it, and carbon has been what? Oxidized. Carbon is now oxidized, and that is what? Definition of oxidation and reduction. That's redox reaction in terms of what? Oxygen. Now we have another way we can define oxidation and reduction, and we can define it in terms of hydrogen. Yes, I know you remember hydrogen, the lightest substance. No, lightest element. No. Now I want to define in terms of hydrogen. Let's begin with oxidation. Oxidation actually is the addition, the removal of hydrogen from a substance. The removal of hydrogen from a substance. So you can have a substance that has hydrogen as one of the elements in that substance. But when it reacts with, let's say, another substance, which in this case can be a very strong oxidizing agent, that hydrogen gets removed. And you're not going to have the substance that was having hydrogen in the first instance is no longer having hydrogen again. Why? Because it has been removed. And I'm going to show you an example here of a chemical equation. Now you can see this substance here. That is, the substance here is hydrogen sulfide, and you can see it has what? Hydrogen. That's the hydrogen. Now it reacts with chlorine gas, and I told you, in order for this to happen, a substance that will remove the hydrogen has to be present, and this substance is a strong oxidizing agent. I told you we are going to be discussing this in the next class, and I know you're going to be looking forward to it. You see that? Now what happens is that this chlorine removes the hydrogen from hydrogen sulfide. Yes, it removes the hydrogen for hydrogen sulfide. Why does it remove the hydrogen? Because it is the agent of oxidation. It is the agent that removes hydrogen. So it removes hydrogen from hydrogen sulfide, and look at what happens here. At the end of the day, hydrogen sulfide is not going to be having hydrogen anymore. It will now be oxidized. It will now be oxidized. That means hydrogen has been removed. Hydrogen sulfide has now been oxidized to sulfur. But you can see here that chlorine now has hydrogen added to it. Here we're having chlorine gas only, but in the product side we now have that hydrogen has now been added to it. The chlorine has now acquired hydrogen, if you can use that word. Why? The hydrogen removed from hydrogen sulfide has now been added to it, and now we have hydrogen chloride. The name of that process, or what we call that process, is reduction. We're going to define it shortly. Okay, here it is. Reduction is the addition of hydrogen to a substance. Like I said, we can use this example. Hydrogen has been added to chlorine gas, and now chlorine gas is no longer chlorine gas, it's now hydrogen chloride. But I'm going to give you another example here, an example I'm sure you love. You have magnesium reacting with hydrochloric acid. Now you observe that in this place, hydrochloric acid is having hydrogen. But look at what happens here now. This one is no longer going to have hydrogen. It is now reduced. Hydrogen has in short been removed. Now I'm going to move on to the next where we can define oxidation and reduction, and it is in terms of electron transfer. And I want you to take note of this one because electron transfer is a type of, it happens virtually in all reactions in electrochemistry. When you talk about chemistry that has to do with movement of electrons, like electrolysis, are you seeing that? So it happens in all forms of electrochemistry, and we can define oxidation and reduction in terms of electron transfer. Now let's begin with oxidation. Oxidation involves the loss of electron. What that basically means is that anytime there's a loss of electron by a substance, in most cases metals, metals generally lose electron. Metals have a characteristic where they generally lose electrons, so we can say metals mostly undergo oxidation. So when there's a loss of electron by a substance, that substance has been oxidized, as I said, especially metals. What about reduction? As you can see here, reduction involves a gain of electrons, and like most of you know, substances that usually gain electrons are usually non-metals. So non-metals have these characteristics of gaining electrons. They have a general characteristics where they gain electrons. So that's the definition in terms of electron transfer. Now what we're going to do now is that I'm going to show you example of this type of reaction that involves a loss of electron, and here it is. Now I want you to observe how you have two substances, sodium, here and fluorine. Here we have sodium and here we have fluorine. Both of them are going to react, and I'm going to show you the reaction soon. But you observe that sodium loses electron to fluorine, which is a strong electronegative element. And as sodium loses electrons, sodium undergoes what? Yes, I'm sure you get it right. It undergoes oxidation. Now fluorine gains that electron. You see, fluorine gains that electron to become reduced. Why? Because the gaining of electrons is a process we call reduction. So fluorine gets what? Reduced. And you can see fluorine is a non-metal while sodium is a metal. Now this is the equation for the reaction. Sodium reacts with fluorine gas to give you sodium fluoride. Now observe the fact that when it loses electrons, when they lose electrons, they become ions. As you can see here, sodium becomes a positive charged ion, which we call your cation. It becomes oxidized to become a cation, while your fluorine becomes reduced to become your anion. Take time to spell that. Anion. So that's a chemical reaction. So we have here sodium is oxidized by losing electron, while fluorine is reduced by gaining electrons. Now let's go to our final definition for oxidation and reduction. Now oxidation and reduction can also be defined in terms of oxidation number, and in this place it is basically an increase, oxidation, that is, in the oxidation number of a substance. When the oxidation number of a substance increases, in the case of sodium, you have it increased from 0 to +1. Take note of the fact that it is the charges you have here, 0 to +1. From 0 here to +1 here, that's an increase. But reduction is a decrease in the oxidation number. That's fluorine has a number of 0. When it gains 1 electron, it becomes a fluoride ion, and that means it has a negative charge. And what happens is that it has decreased from 0 to -1. That's the decrease is in the positive direction. So I'm sure you enjoyed the class, and you can also be able to answer the questions and quizzes you have at the end of the day. So thank you from this camp. God bless.